And thanks for giving me a chance to tell you a little about Platypus. Platypus is a company we spun out of the Robotics Institute to take some of our mobile robot technology out into the world. I'm going to tell you a little bit about how we did that. So Manuel has just been talking about autonomy, and typically when we think about autonomy, we typically think if a robot's really simple, it can't be very autonomous, there's not very much it can do. We have to make it more complex, we have to put more sensors and more computers and more things on board to actually get it to do anything useful in the world. We tend to think that the graph goes like this. So we tend to think that the graph goes this way. The robot has to be more autonomous in order to do more interesting things. The trouble with that is that additional complexity typically requires more manpower and certainly requires more cost. So whereas a simple robot can be run by a child, these complex robots need big teams of PhDs to take them anywhere. And what that means is that extra cost means that we tend not to take them places. There's a high bar on actually taking them out into the world. So it's the complex robots tend not to be as autonomous as simple robots. People and the cost goes up. The reality is it goes in the other direction. It's the really simple robots, as iRobot showed so well, that are actually autonomous. They're the ones that actually get out in the world and do things. And that's the philosophy behind Platypus. In our case, we build robotic boats that go out into inland water and collect information. So why do we do water? Well, it turns out that water and robotics go very well together. A lot of the technical challenges that we would normally face with robotics don't happen to us in a place like this. Two-dimensional environment, there's no obstacles, it's really easy to get around. It's nice and flat and it's nice and simple. But there's tons of it. There's lots of places that we can take our robots and there's lots of water that we care about even when we consider inland environments only. Not this particular lake, but much of it is dull, dirty, and dangerous. Our motto as roboticists, places that people don't want to go, but we want to send robots. But while it's technically fairly straightforward to take robots out into these environments, water is fascinatingly interesting. This is some salinity data that we took in a lake near Pittsburgh, showing how complex the salt is over a fairly small area, and this is effectively the pollution across that lake. This is bathymetry data on a boat channel and showing the bottom. So water is interesting across 3 and actually 4 dimensions because this will change very rapidly over time. So we've got this really nice environment where the technology required of the robots is fairly simple, but the environment is really fantastic for the sort of information collection that we want to do. So that's what we do. This is our basic boat. It's about 2.5 feet long, weighs about 20 pounds. And we make the hardware very simple with 3 basic tricks. Firstly, we use an Android phone to pretty much give us everything we need on board. It gives us a computer, communications, GPS, a camera, everything we need to move this robot around the world. We keep the moving parts as few as we can to give us robustness. In this case, we've only got 2 moving parts. But we pack it full of sensor ports so we can grab up as much of that data as we can, because the data is what's important in the end. That's what our basic robot looks like. The technology is fairly simple, the hardware technology is fairly simple, but we make it powerful by bringing along all these intelligent algorithms, stuff that's been coming out of our lab, and all the stuff that Manuela and everybody else at Robotics Institute does. So we bring across these algorithms to do 3 basic things for us. Firstly, we make the boat autonomous. We don't have to sit there from the shore and control this thing, it can go out and do everything by itself. My background is in cooperation. So we can get robots to work together to go and either cover bigger areas or cover them faster than they could otherwise. This is in the Philippines. And we get them to be reactive to what they're sensing in the world. As Manuela again was showing the information the robots collect, our robots look at the information they're collecting and decide where to go next. So you put all these 3 things together, and although we have a simple hardware platform, we've got the ability to go out and get the right data and get it fast and autonomously. As I said, the core to what we're doing is the electronics. It's the intelligence, it's the AI on board. The form of the robot, the actual physical robot, isn't important for us at all. And in fact, what we can go off and do is build different forms of the robot depending on the environment we want to go into. If you consider this, these are all dogs. They're 99.9% the same thing, but by changing the body a little bit, changing their sensors a little bit, they've got very, very different functions that they can perform for society. Platypus thinks in exactly the same way. We've got our electronics board that allows us to control our motors and connect to the sensors. Pretty simple custom-made device. We've got our Android phone, we have our app, where all our local intelligence, and then we have our algorithms that let us do all the smart stuff. And we can wrap that in a variety of different boats. These are some of the ones that we've built. And we can take these out in very different environments, from the small airboat in the bottom left-hand corner that can work in 2-inch deep water, to the catamaran that can go out in 6-foot high waves. Exactly the same system, very low barrier to creating a new body for these boats as we find a new market or a new environment that we need to go into, because all the hard work's already been done. So what this gives us, a low-cost, robust technology platform with smart algorithms, allows us to go out into the world, which was what I said we wanted to do in the first place. And so we have. I'm just going to give you a couple of examples. We've been all over the place. A couple of examples of what we're doing in different places around the world. Over in China, we're looking at pollution and look like we're going to start a subsidiary there to do aquaculture in the very near term. This is one of our customers, sent a picture of our boat in Western Australia, surrounded by black swans. In Pittsburgh, we do a lot of work with energy companies and environmental groups. As Lenore said, we've been over to Africa and looked into hippopotamus-infested rivers. The only way they've ever tested anything about this water is with our robots. We have an ongoing CMU project over in Qatar, where we're going to put 25 boats in the water together later on this year and collectively measure a very large area and understand much more about what's going on in water at one moment in time that's been possible before. And our very first project we're still very proud of was to take the boats over to the Philippines and sit through a typhoon and run them around in post-typhoon water. And we did actually let kids run this. It didn't take 12 PhDs. So all this is cool. We did what we wanted. We built cool robots. But how is this a business? Well, the business has nothing to do with robotics. The business is all about data. What we've got is a platform that can go and collect data at very low cost, high reliability. So when I go and talk to customers, I don't tell them anything about the robots. Well, actually I do, but I shouldn't. I tell them all about the data that these robots can collect and how it can change their business. There's many markets out there where people already have to collect huge amounts of data. They have to collect it on a recurring basis, things like EPA compliance, lake management, aquaculture, and there's special purpose projects like responding to and recovering from a flood, where you want to know where the silt's moved and where you have to dredge. And all these customers either are collecting information in a manual way now, which is very expensive, or they're not getting information that has big, serious economic value to them at all, because there is no economically feasible way to give them. To just give you an example, so these markets are absolutely huge. These aren't toy markets. Each of these markets is multiple $1 billion on their own. $18 billion, for example, is spent on EPA compliance work. 30% of the world's fresh fish is actually freshwater aquaculture that our products are potentially applicable to. To give you a feel for what the service we're providing is, this is just an example. Our small boats are costing us about $1,000 to put together. And in about 30 minutes, someone with minimal training can take them out in a 1-acre pond, equipped with 4 sensors, and collect about 5,000 data points. This is 2 to 3 orders of magnitude cheaper, both in terms of the amount of data you can get per dollar and the amount of data you can get per time, than any other process out there at the moment. And we can collect a whole bunch of different things that different people are interested in, and that list is expanding almost daily. The whole platform's designed to plug in new sensors as we work out their value. If you're interested in knowing any more, check us out on the web, check out our blog, where you get to see lots of videos of hippopotamuses chasing our boats, or talk to me afterwards at the networking. Thank you.